Hey everybody, welcome back. So we're at Hack the Box again, and we're going to do Aragog this time. Sorry if I pronounced that wrong to any of the Harry Potter fans out there. Never watched it, so I don't really know if that's the right way to say it, but anyway. So this is another Linux box, and this one's got a slightly higher difficulty, as you can see, than some of the other ones we've done. So again, let's just go ahead and dig right in. Pop open our terminal and let's clear this out. Start out as always with our quick nmap nmap t5. Just let it actually do the standard ports and output all to quick scan. 10.10.10.78 and make sure I'm actually connected. Looks good. Alright, and so looks like we've got FTP open SSH and HTTP. So why don't we go ahead and take a quick look at what we've got on the web server. And it looks like we've got the default Apache page, so nothing super interesting here yet. Let's go ahead and fire up Dirbuster, and then we'll get it going, and while it's running we'll take a look at some of the FTP server stuff. Crank our threads up. PHP pages for now is probably fine. These are share word lists. Dirbuster, and we'll take medium one, and we'll get this going. Let's minimize that. Let's take a look at the FTP server and just see if we see anything obvious. FTP 10.10.10.78. It wants a username. We'll just tell FTP. Oh, it's only okay. Open 10.10.10.78. Non-endless. Just apparently having a hard time here. Just kill out of that. I think we may have lost our connection again. Yeah, I think this. It's possible I'm having some connectivity issues here, so we'll see if we're running again. Okay, so we're good here. Dirbuster had a heart attack because of the disconnects. So we'll start it again. Anonymous. Okay, and so under one file, test.txt, let's get it. Get test.txt. So that should be downloaded into the directory we're on. I assume we can't actually change directory. Yeah. Okay, so let's get out of the FTP server for now. Let's take a look at that test.txt we grabbed. Cat test.txt, and looks like an XML blurb. Details and a subnet mask. Okay. And then test field. Let's see if we got anything interesting for Dirbuster yet. We've got a couple directories that are standard, and we've got a file called hosts.php, which I'm guessing ties in with this somehow. But let's pull open a web browser and take a look. Hosts.php. There are 429496729 possible hosts for, and nothing at the end here. I believe that's that's as many hosts as you would get in the entire internet or IPv4 space. So I'm betting that this test.txt file is used for input to that hosts page in order to calculate how many hosts there are given a specific subnet mask. And I don't see anything else interesting here yet, so let's just, it looks like it's actually finished. So while we're messing with some of this other stuff, let's get us started on a couple other extensions. Just to see, it's probably good, just to see if there's anything interesting with those. I'm betting we lost our connection again. Weird. Alright, I'm going to pause this video for just a second, reboot everything, and that way hopefully we stop having this issue. Alright, and I'm back. I'm going to get reconnected. So just in case somebody's curious, or if you ever run across this problem where you keep losing connectivity, if you do what I do, which is I run a lot of these on my laptop, just so that I can sit around the house or do whatever. And then I happen to do these videos on my desktop, and so what I had done is I had left my laptop connected to the VPN as well, and with OpenVPN, for whatever reason, I'm assuming a configuration setting, it allows us both to be connected. But presumably whoever sends a packet or more recently, like if my laptop did, then all of the traffic starts going back to it instead of back to this side, and so this guy effectively gets disconnected. So anyway, disconnected that, so we should not see any issues caused by that anymore. And so now let's get this started going again, and let's see, that's right, we had our host.php file that we wanted to take a look at. And so since we assumed that the XML is posted to this web page and then it provides a result, we need a tool to create a post request. There is a million ways to do this, whatever you prefer. I happen to use the REST client plugin in Firefox just because it's easy. There's other great tools out there. There's Postman is a really good one. It's nice because it's cloud-based and it keeps all of your records of all the post requests or GET requests or whatever you've ever done. It's for testing RESTful APIs. In this case, I just go for the easy thing, but pick whatever flavor works for you. Sorry, now my VM seems to be acting up as well. .78/hosts.php. I might be getting a little too aggressive with this Dirbuster scan since it's in a VM that I haven't dedicated a lot of resources to. So for now, I'm going to go ahead and pause this. Maybe. And for our body, we're going to want to take the contents, it's right up there, the contents of this XML file. Stick that in there. We'll send it up, and we get a 200 response, and we get there are 62 possible hosts for 255.255.192, which is correct. So it looks like it is indeed taking this subnet mask field and calculating the number of possible hosts. Let's see if this test field does anything useful, or if it's just sitting there. Doesn't seem to. Let's see how this handles just something that's not what it expects. There are blah, 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 possible hosts for ... Okay, so it doesn't seem to care. Possible hosts for blank. Possible hosts for... Okay. So easy enough, as long as it's getting something in the subnet mask field, it's happy. It tries to do its calculation if it results in the max value. I'm assuming if we send it some invalid XML, no, it still seems to seems to like that also. Okay, so this raises the possibility of one way of getting access to some of the information on this system, and that's through a technique called XXE, or XML External Entity Injection. And so what we can do to test this out is let's start up a local web server, Python simple HTTP server on port 80. So we'll just fire up our Python web server. And then what we're going to do is add some XML external entity tags at the top. And we're going to try to see if we can get this server to reach out to our web server. If we can, then we know that it allows external entities. So we'll just do equals. And by the way, you can look up some standard ones. They're on OWASP or plenty of other sites. So you don't have to know all of this by heart. Food. And to do food. Which that kind of applies to everything, by the way. Like, if you're not already aware, memorizing things in this day and age, while sometimes helpful, and usually a byproduct of just, you type it enough, you end up remembering it, it's not as important as it used to be. It's easy enough to just quickly Google something. To me, it's a lot more important to know just enough to know how to find the things that you need. I think that should be good. Just in case it doesn't trigger unless... Okay, and so what we're doing here is we're creating an external entity, and we're telling it to go get this entity from this source. And then we're telling it to output the results of that here. And so if we hit send, we get back our standard 200, nothing surprising there. And if we take a look here, we can see that it did indeed ask for test.txt. So this is promising in that it lets us know that it's vulnerable to XML external entity injection. And so let's see if we can do something slightly more useful here than telling it to go to our web server. Let's instead try and see if we can get it to get a file. In this case, it's the passwords file. The reason that we would want that, of course, is so we can see which users are on the system. Almost nobody actually has passwords in there anymore, but it allows us to enumerate the users. And we get it back here, so it still tried to parse it, and then it tacked on the results here. This doesn't look right, though. There's not enough lines here. There should be a lot more than this in most modern Linux systems. So I think for some reason we're not getting the entire result. There's another trick that we can use, which is adding a PHP PHP wrapper around this, and we'll actually also encode it. That way it's possible what's happening is one of the values that's getting returned is something that the XML parser or the web server, something along the chain, understands, and so it's interpreting that as the end of the response. So in order to prevent that, we'll base64 encode what we're asking for, which adds an additional step to what we're going to try and do, but and I'm going to open burp here just to make it easier to decode the base64 responses. Or actually, let's just pull open a web page to do it. It's probably just as easy. Okay. And so then what we want to do is wrap this with PHP wrapper. So we're going to use filter convert.base64 encode. And then we're going to tell it we want a resource. And that resource is going to be Etsy password. And the closing quote, I think this is good. Let's try and send it, see what happens. So we did get back a base64 encoded result. Let's copy this, paste it there, decode it. Okay, and so now let's take that, put it somewhere easier to see. So now we got back the entire contents of the password file. And so before it looks like we were cutting off after news, so something along here caused it to stop. And so what we want to do here is basically look for accounts that we feel we can use. I'll save this too. It's always a good idea to save stuff as you go. That way, if you leave, get disconnected, whatever, something happens, you've got your results there so that you can continue working. Let's save that. I'll close out of this. Kill that. Okay, so cat password. It's cat password, and then let's grep bash. Oh, sorry. Oops, if I actually type grep. Okay, and so there's 3 accounts that use bash shells. And so it's root, Florian, and Cliff. So now we've got the 3 of the most likely users on the system that we can get access to. The rest of these, most of these look like they're using bin false, or let's see also, just a sh. So the same thing other than we picked up SSHD, which doesn't allow logins. So we've got our 3 basic accounts here that we're going to try and use to get access. We can extend our XML external entity attack to look for the, well, we can actually, wasn't intending on doing this, but we can just see if we can find the user.txt file. User.txt. And we got back nothing, so that doesn't exist. Other one was Florian. And we get a blur back here. Remember, this is base64 encoded. We could probably, let's put this in buffer for a second. We could probably do something like this if we didn't want it to be base64 encoded, or if we didn't want to waste the time decoding it, I should say. Okay, so there's the user. The user's flag. But I'm guessing this isn't going to work for getting us the root one, because that would just be a little too easy. Yeah. Okay, so let's put our PHP wrapper back in there. And so now we have to see how we can actually get into the system. try using XML external entity injection to get it to execute a command to connect back to us, for example. I don't know of any way to get it to execute arbitrary commands, so I'm going to try something that's a little easier first, which is seeing if Florian here has any SSH keys. And so when you set up your account to allow public-private key authentication for SSH, your keys will be stored in this directory under, I believe it's IDRSA, .pub, and then IDRSA without the .pub is your private key file. And so since we'd seen earlier that port 22 is open, it's reasonable to assume that they have SSH set up. And it looks like we got a value back here. Okay, so this looks like public key. By the way, if this was for a real pen test or something, don't use a generic website to decode stuff. Do it all locally, because you don't know what they're saving. So just as a side note, this is for the ease of making the video, not for general best practices. Okay, so what we'll do is sorry, I actually meant to close that. Let's save this, and then IDRSA, that was the pub one. And let's see if we are lucky enough to get the private one as well. Oops. It appears so. It's possible this is encrypted like some of the other ones we've seen, so let's not get our hopes up just yet. Doesn't appear to be, it would say encrypted. It was. So let's save that. And so let's see if we can SSH in as Florian. -I IDRSA is the key we want to use. Florian at 10.10.10.78, I believe. Yeah. 78. Oh, as I pointed out before, you got to make sure that you set the proper permissions on your SSH keys, because it won't actually allow you to use them if they're not set right. So if we sudo mod 600 IDRSA, so now we should be good. Let's cat IDRSA real quick. Okay. The reason I was catting that is previously, and it may have been attributed to something else, when I had tried to use a key that wasn't properly protected, the key got blanked out somewhere. And it looks like we're in as Florian. Do an ls. There's our user.txt file, cat user.txt. And so again, we had already actually grabbed this through our XML external entity injection, but we can grab it for this also. Except I didn't actually grab it. Okay. And so now we're going to try and see how we get ourselves from user to root. And so in the usual way, we'll take a look here, make sure there's nothing super interesting in here. Text, ls, la on desktop, nothing interesting, la on documents. I'm not actually going to worry about the other ones right now. So let's change directory to dev shm, which is our RAM drive, and let's make a temporary directory. Make it hidden. so it's a little less obvious to people. Assume there's nothing in here yet? Okay. And so, as with most challenges, and I know people hate to hear this on the forums, you got to start enumerating. First thing is always enumerate. Get your scripts over, get them running, see what turns up. So let's get into directory where I keep my stuff like that. And let's start up a Python web server. And then let's get sorry, my hotkeys here aren't working. Let's call it Python web server. So I don't know what's going on. I actually paused the video for a second and closed out that tmux window. It's still, key's not working, so I'm just going to create another terminal window. Start tmux up in it. This one's working, okay. So who knows what the deal with that was? It's not that important. Let's, oops. Let's drop that into tools folder. Let's start a Python web server. Simple. Let's go back to this window and let's grab our Linux enum script. Okay, I don't know what to do with that was. wget enum.sh. Don't forget the port number. Okay, let's see if mod it. Executable. And let's dump it to enum.txt. Let's do this first. Let's run on it and then dump the output of that to enum. Tmux problem apparently threw me off my game. Okay, and that's done. So let's enum.txt install enum.txt. Okay, and let's look in here for anything interesting. So we're running on Ubuntu 16.04 LTS. It's possible we have some kernel exploits that would work. Although at least I've found on most of these systems, they don't intentionally allow that. They try and make things a little more nuanced. The kernel's also fairly new. So the system is Aragog. User Florian's logged in. We've already seen which users we have. We've already seen these entries. Looks like we don't have the ability to read Cliff's home directory, or roots, of course. Root logins allowed via SSH. Environmental variables, see if we see anything interesting there. Okay, so far nothing interesting in any of these. The cron job stuff looks interesting. We already know about the network configuration. Nothing new there, nothing new with the default route. Connections, 22.631, which is cups, I believe. 3306 is a MySQL server, so that's interesting. We didn't see that from the outside, so that's only listening on the inside. We see our established connection, and then we see something on, it's probably the connection that was used. It's going to the local host. Yeah, so we've got something where we've got something on the local machine in time-wait state connecting to the local host's web server, so that may be interesting. It's also possible it's just somebody else that was on the system's old connection. And then the services that are running. So we see MySQL D right here. We also see that our FTP server is running FTPD. You can see if the version that it's running has any known exploits. Bunch of Apache and quite a few lineage names actually, so it's possible somebody else is on here too. Although those are all at the same time, so anyway, irrelevant. Okay, and so far everything here looks fairly normal. Sudo version, our Apache's running as data, that's all normal. Apache's home directory. So it looks like we've got, oh, we didn't see this. So we've got devwiki, which is a directory, and it's running as Cliff, so that might be worth looking at. And its permissions are really lax, so that may be a potential issue. And then we've got a ZZZ backup directory also that we didn't see. And then the index HTML and the host PHP, we already saw those. So devwiki, as you can see here, it looks like whoever set this up didn't do a tremendous job with the permissions because everybody has access to everything. Looks like that's going to persist throughout this entire devwiki directory, which, given that all these WP files, WP-admin directory, this is all WordPress, I'm guessing. And so it looks like an entire WordPress installation that was done improperly, so that could be interesting. Let's see if we get anything about that ZZZ backup directory. Includes lots and lots of stuff in here, but that's normal for a WordPress install. They're huge. That's interesting. So ZZZ backups permissions look a little strange. I don't know that I've actually seen this before, so all the permissions seem to be screwed up, or we can't enumerate them. It knows that these files are in the ZZZ backup directory, but it doesn't know what the permissions are on them, doesn't know who the owner is. So that may be interesting as well, although if it can't get any of this, we probably can't touch it, so I don't know that it's that interesting, but just something to keep in the back of your mind. So then we've got all the comp files that we could access, and that's about it. So let's quit out of this and let's take a poke through this var.html wiki. And so as you can see in here, permissions are all screwed up. Everybody's got read, write, execute. So first thing we want to look at then is our WP config. .php. There should be a password in here. And there is. So I was going to say, this is where you normally would have your configuration information, such as your connection to your MySQL database. Copy that. Let's see if we can find what username is. Oh, there we go. Define DB user root. Okay, so username's root. Password is this big string MySQL -u root p. Paste. Okay, so we're in MySQL as a root user. Let's see. So let's see. We can do anything interesting in here. Okay, and so we can execute some shell commands through here, but I'm guessing that, yeah, that this is all just done in our own context, so that doesn't do any good for us. So let's see what databases we have. Show databases. WP Wiki, MySQL, and everything here is pretty normal other than WP Wiki, so let's use WP Wiki. Show tables. Okay, and so let's see what we have in the users table. Let's select star from WP users. Something tells me that second entry is not part of the normal system. So we've got an administrator account which has a MD5 encrypted password that's been salted, and we've got a hacker account with a unsalted MD5, it looks like, with a display name of Hacker Deluxe. So I'm gonna actually ignore that one for now, just because, I mean, you could poke at it, see if, actually, let's, just for shits and giggles, let's see if anything online has that MD5. You gotta confirm that you're not a robot. Robots aren't allowed to crack. Oh. And so the password is super hacker. So we can see if we can do something with that on the WordPress site. I suppose we could also try and log into either the Cliff or the root account with it, but I'm guessing it's not going to go anywhere. This password isn't worth trying to crack because it's salted, so it's more work. This one just wasn't salted, was the reason that we decided to look it up and actually found it. Something. So let's go ahead and let's quit out of this. Sorry, what was this? Excellent password, super hacker. So just in case so we don't miss anything, let's try SU Cliff super hacker. Failed SU root super hacker. Also failed. So no real surprise there. So let's try and see what this DevWiki site's all about. Did not do what we wanted to do. And it tried to redirect to Aragog DevWiki. So we've got a slight issue there in that we don't know who Aragog is, at least as far as our system's concerned. So let's fix that. Let's kill this because we don't care about that for now. And let's edit our host file. And so let's add an entry, so 10.10.10.78 Aragog. So this should solve that issue that we saw there. And so now when it tries to get Aragog DevWiki, it will actually have an IP address that it can map that to. And we get DevWiki, just another WordPress site, and so it looks like, welcome to your WordPress site, looks like an unset up WordPress installation. Nothing super interesting here other than there's a message to Florian, it looks like. Hey Florian, thought we could use a wiki, feel free to log in and have a poke around. which is interesting because I didn't see a login for Florian there, so I don't know how he would unless he happens to know if it's a shared administrator password or something, I suppose. But as I'm messing around with a lot of changes, I'll probably be restoring from the site backup fairly frequently. Okay, so that can lead us to believe that if we make changes in that directory, because remember we saw that we can do anything we want in there, that they're likely to get overridden at some point in time. He'll also be logging in regularly and email the wider team when he needs some more testers. So emailing the wider team may mean something for us. We could look at the mail spooler. And him logging in regularly may be a good thing too. So since, if this was a live site, I may treat it slightly differently than I'm going to with this one, just because this is a challenge, and so we know that there's likely not a person who's really sitting there and logging in at regular intervals, or that's doing the restores at regular intervals. It's likely to be something that's run in an automated fashion. So we can usually take a look on the system, run top or something, look for anything that pops up that's suspicious. Depending on how long things run, it may or may not be useful. I typically don't find it useful. So I've actually previously written a script to help with this. It's available publicly on GitHub. It's crappy, so don't expect too much out of it, but it does what I need it to do. It's available in my gists, which I'm not actually super sure how I find without logging in, which I didn't really want to do, especially with all of you watching. So just a second, let me pause this, log in, and I'll find it. Okay, sorry about that. So we're back, and here is the program that we're going to use to watch for processes. Now, this is written in Go. You could technically write the same thing in Python or any other language that you wanted. There's nothing too special about it. It just basically watches the proc directory for new processes to be spawned and then grabs some of the stuff like the command line arguments and who the owner is. The only reason I chose to write it in Go, and I like to write a lot of my tools in Go, is because if they have a lot of external dependencies or other things that may or may not be present on the target system, they'll be built into my executable. I create a static executable. They don't require any sort of scripting host. You can obviously do that with Python also. There's ways to create executables, package everything together. To me, this is just easier. Do whatever floats your boat. And so let's pop open a window here and let's save this as save it as procwatch.go. Close that. And it should be in here, go build procwatch.go. So now we should have a procwatch. And so let's start up our web server. Python-m simple server. I should have probably tested it first to make sure that it's working, but I've used it enough that I'm not too concerned with that. So let's switch back to our top secret directory. Again, just so that we're not leaving stuff out for people to mess with that may help them in a way that they wouldn't have otherwise figured out. Get didn't do a port, so it defaults to 8000. Teach me to not pay attention. So let's make this executable. And let's execute it. And so right now it's kind of ghetto on the first run. It goes through every single process that exists, but now it should just be looking at things that people are executing in real time. And so we can see shell of union-p with the error being dumped to dev null, and it's being ran by Cliff. I'm not sure why exactly he would be doing that. So unfortunately, this is going to be the boring part of waiting for something interesting. So what I'm going to do to save you the trouble is I'll pause this video. When I unpause it, we'll hopefully have something interesting on the screen if there's something interesting to see. Which actually, as I'm saying that, I looked right above it. There is actually some interesting stuff to see already. So, let's see. So right above that, we see I'm using ldconfig. We see a cron job trying to execute, except for that's not going to work because cron's not uppercase. Which actually, not really sure what the root of that is. I've seen that on regular Linux systems a bunch. I'm sure there's some reason that it does it, but whatever the reason is, I'm not sure. This is what I find a little more interesting. So he's got a script in his home directory called wp-login, and he's executing that fairly frequently. And so he's executing it again here. He's executing it again here. So that's actually being executed, it looks like, maybe every minute or so. I still haven't seen any sign of him cleaning out that directory, which is good, because if he was doing that too frequently, that could make any sort of attack that leverages changing stuff in there difficult. And so it looks like we see again he's running this wp-login.py, and we can hypothesize that what he's doing here is executing a script that logs into the WordPress site, presumably to simulate the user Cliff logging in. We can also see if this happens to be something that's pretty standard by Googling for it. Oops, I didn't actually mean to click on that. It looks like there is a script. We don't know that this is necessarily the same script they're running, but there's a script here. It looks like it has a destination. It goes for wp-login.php, which is what I was expecting. It's got a cookie. It's got a set of usernames and passwords. It tries, it looks like. Yeah, so it makes a request. It's looking if it gets a 400. If it gets the title dashboard, then it prints success. And so it looks like it's just testing to see if it can log in or not. Now, we don't know necessarily that this is what that script is because, again, if it's in a directory where we can't access it, which it is, somebody could have just chosen the same name. It's not like wp-login.py is a huge stretch from wp-login.php. A couple important things to notice here is that it's making the request directly to localhost on some port. Again, presumably they've edited this because they're running on port 80. But this could prevent us from doing things like editing the wp-login script to have it post the login credentials to, say, our local server instead, which is something you could normally do. So you'd replace the post request where it posts to itself with a post request to your local web server that's running, and then you could capture the login credentials. In this case, because it looks like they're posting directly to a hard-coded page, that wouldn't work. We could replace it in the WP login file, but they wouldn't actually use it. They would do their post anyway to their hard-coded one. So that only really leaves us with one other choice, which we'll do here in just a second. Okay, so here is, yeah, this is where it's restoring from this easy backup to DevWiki, and so it looks like he did it at 9:45. So my guess is maybe he's doing it every 5 minutes or so, which would mean we don't have a ton of time to do this. So why don't let's pull the WP login page down to our working directory here, and then we can see what we can do to try and capture the credentials. So if we do a copy var HTML DevWiki WP login PHP to WP login. So now we've got that. Just to make sure that we're not bypassing anything super simple, let's try and cat cliff wp login.py. I assume we can't access this, yeah. So wp login, well, part of that's typed wrong. Login. Yeah, so that's a mystery what it does, but I think the name of it should at least provide us with a bit of a clue. So let's take a look real quick. Sorry, I keep forgetting we don't have Vim over here. wp login.py. And so this is the normal WordPress login page. It's incredibly big. There's a bunch of stuff that it does. It supports the lost password functions, regular login, password reset form, all these things. We don't care about any of that right now. What we'll do instead is go to the top and just inside our PHP script tag. This looks like a good spot. Let's put some PHP code that should allow us to dump all of our post request variables to a file. So JSON val or JSON code, and so we're encoding this in JSON just to make it a little easier. Post file h. So that's our file handle, and it's going to be equal to fopen. And this needs to be somewhere that it can write to, so it's usually a pretty safe bet that it can write to login, or sorry, to the temp directory. And we'll write a login.txt file. And so then we'll do an f, right? File h, and we'll write our JSON val. And then we'll close the file. So that should be good. Let's see what time it is. So we just passed the 5-minute mark. Let's see if we run proc watch, if we can see here. Yeah, I don't see any history of his overwrite, but we only have from 38 seconds after on, so it's possible we just missed it. In either case, we'll go ahead and we'll bet that we have time. So let's copy our WP. Well, first let's look and make sure we don't have anything in temp. We already have a login there. I don't want to give up too much information yet, so let's see. April 18th. So that's actually probably me being a slacker. Given the name of the file and the fact that I haven't released this video yet, I'm going to say that I'm the one that was bad here. Let's remove that. I can't because it's on my www data right now. So again, just to help make this video a little more reasonable, let's use a different file just so that we can prove to ourselves that this was working. Okay, actually, let's make it login.log. Oops, I need to actually make that a capital G, but whatever. So that looks good. And so let's cp login to bar.html wiki. So now let's see if we can wait to watch him execute his login script. While we're waiting for that. So that's another reason why I suggest resetting systems after you're done with them if nobody else appears to be on there, which I did not do, and I thought I had cleaned everything up manually, but I'd obviously missed something. So it looks like he logged in, so let's see if we have something in there now. SLA temp, got a login.log. Oh, I had apparently called it login.log before instead of login.txt. Anyway, so I guess it's a good thing that I messed that up and made it a capital G. So let's cat. And so it looks like we have got his post variables here. And so we've got one called password, WP submit, test cookie, log administrator, and a redirect. And so, of course, administrator being the administrator name, or the account name, and this password here are the things we're interested in. We could try logging into the WordPress site as the administrator and see if there's anything interesting. So we can do that in just a second. Let's also just try real quick, SU to Cliff, to see if we can switch users using this password. No. Yes. And so now we've got root. So let's see, cd root.text. Text. And there we have it. That's our root flag. So we have both our user and our root flags now. And so let's go ahead, and I'm actually going to restart this system to clean it up since I don't think anybody else is on right now. But you could also just manually clean up. You can assume that your WP login is going to be overwritten in a second when it overwrites anyway. Actually, in this case, it looks like it probably already was. So let's just rm-r shm, and then let's rm. Just clear out everything in temp. Stuff that's left behind is of no concern to us. Now again, what I just did right there, if somebody else was on the system, that could have been a huge dickhead move if they had stuff on there. So clean up your own stuff normally. In this case, I just assumed nobody else was on the system, which is probably bad. And so that's it now. Everything should be cleaned up. Like I said, I'm actually going to request a restart on this anyway in case I left other stuff behind. But there you go. That's how you do Aragog.